Welcome to Python for Scientific Computing 1. As we end this journey, let's go back and revisit the course learning outcomes and place all that we have learned so far in that context. The primary goal of this video series is to get STEM students started with Python programming to solve mathematical and scientific problems. We selected Python over other programming languages because it's fairly easy to learn, because it has English-like syntax. Its functionality is greatly enhanced by the availability of a large number of libraries to perform scientific tasks. In addition, Python is being rapidly integrated into other softwares such as spreadsheets, GIS, and CAD. So having a fundamental understanding of Python also helps you with getting better at these other ancillary software that we use in engineering and sciences. Our learning outcomes before we embarked on this course were to, one, remember the basic syntax of Python, or at least use generative AI and web searches to find it. We wanted to understand various data types and data structures in Python, both that are available natively, such as lists, tuples, dictionaries, and those that are added by commonly used libraries such as NumPy and Pandas. NumPy, for example, adds the ND-array data structure that helps you work with matrices and higher dimensional data. We wanted to apply procedure-oriented programming concepts such as branching, iterations, and also demonstrate how user-defined functions can be written natively in Python. In addition, we wanted to learn about available libraries for performing advanced scientific tasks such as matrix algebra. We looked at NumPy for this purpose, and then how to read tabular data and perform exploratory analysis using Pandas, and then create charts and other visualization using Matplotlib library. In terms of Bloom's taxonomy, our focus in this course has been more at the lower echelons of learning. That is, we want to remember some syntax, understand the various ideas or concepts that are available to us natively in Python and with some additional libraries, and apply these to some simple problems. Our learning focus was to get familiar with Python, see what type of calculations and manipulations you can do using Python, and solve some simple introductory problems. We got comfortable with Python syntax. Some statements like print, list should become second nature to you because we have seen it being used over and over again in this course. We made use of the Google Colab cloud platform for programming. This allows you to try out or test out Python without having to download anything on your computer. And Google Colab makes use of the Jupyter Notebook environment, which allows you to integrate text with computing to create notebooks that are self-contained. We also saw several tools and methods that are available to us and worked out some simple examples. While our focus was largely on procedure-oriented programming, we also saw what are some of the main ideas behind object-oriented programming as it's implemented within Python. What we did not do in this course is delve deeply into computational algorithms. We did not create large-scale workflows connecting many programming elements. We did not investigate object-oriented programming in detail, but we used it if it was readily available through libraries, and also saw a basic introduction to the various methods that objects have, as well as the attribute values that they have and how to access them using the dot notation. We did not explore aspects of Python that is not relevant to scientific applications, such as Python's use in web development, database management, and others. The key takeaway here with our learning goals is the students should have sufficient background to take additional advanced concepts by mastering the material that we presented in this video series. What are some of the key takeaways? Some basic syntax should be of second nature. For example, print statement, type statement. We have used them throughout this course, so it should stick. Some basic rules should also be evident. For example, Python indexing always begins with zeros. Arrays and matrices are indexed using row columns as axes. First index is inclusive and the last index is exclusive. And also, for loop is not index based, but it is element based. Of course, you can initialize a list of indices and then use it as part of the loop. We also saw that there is a lot of help on the web. Web searches and generative AI are generally your friends when it comes to helping you learn Python. Notice they may not be able to solve the problem that you have, but at least give you an idea of what kind of syntax can be used. And we also saw how best to use generative AI in terms of learning Python and trying to find simple examples rather than solving more complex problems. Again, some pointers on using generative AI: create very specific prompts. Ask for an example code than just simply feeding your problem and asking you to write code for it. Because keep in mind that generative AI is simply synthesizing information that's on the web, and the problem that you're trying to solve may or may not be available on the web. Always check to make sure that the code provided by generative AI actually works, and then try and see the logic that's behind this and see if the syntax makes sense from that standpoint. Of course, you can always modify the code that's provided by generative AI to meet your needs. Much of Python's functionality depends on libraries. So it's also important that when you prompt generative AI for example code, ask it to include specific libraries so that you get the complete code and the libraries that you may have to download or import before your code runs. Having gone through this course, what are some of the next steps? At this point in time, you have certain tools at your disposal. Clearly, how good you become with these tools depends on how much you practice with it. So think of some problems that you're solving in your school exercises, homework, and assignments, and try to implement them using Python. The more you practice, the better you become. The course should also help you get into using more advanced features in Python that are available through specialized libraries such as the Scientific Python or the SciPy library and the scikit-learn library that is used for machine learning or traditional machine learning, as well as TensorFlow and other advanced machine learning modules that are available in Python. With that, wrap up. I wish you all the very best in your pursuit of learning Python. Keep calm and happy coding.